Hello friends, welcome to C# Intermediate to Advanced tutorial. Now you are watching part 3 of the sub-series C# IComparable interface. In this video we are going to see how to implement IComparable interface on student class. That means we will create a student class. After that we will implement IComparable interface as well as CompareTo method. Those are all the slide decks from previous two parts. Now we will proceed with the example. In this example, we are going to implement IComparable interface. If you see, we have a student class. In Visual Studio IDE, we will create a student class. After that, we will say the student class implements IComparable interface. The student class contains 3 members: student name, student height, and student weight. The first one is a string and the other 2 are integers. Next, we have getter and setter methods, or in C# world it is simply called as a property. We have a property called student name, and this is public, and it performs get and set. Get will read the information from st name, student name. Set will set the information on st name. So these are all private members, and the student class can be accessed. I mean, its internal member can be accessed using these properties: student name, student height, and student weight. Next, we implement CompareTo method. CompareTo method returns an integer. We already talked about this method in theory part. So this is the obj. So each time the collection class, it can be array list or linked list or whatever collection class you use in C#, the moment you make a call to sort, it will make use of this CompareTo method. So CompareTo method requires 2 objects, that means 2 student instance, let's say instance 1 and instance 2. So instance 1 is fixed. Let's say this is fixed. Collection class will first take 1 entry and it will make it as fixed. Then from this object instance, it will make a call to CompareTo method. And 1 or more instance, instead of infinite, I will put 1 or n. 1 is fixed, and after that, if array list, let's say if it contains 3 slats or 4 slats, 1 element will be fixed, and using that instance it will make a call to CompareTo. Then it will pass other instance 1 by 1. So these 2 will come here, and this will be the first one, that means the fixed one. So we call this as one pass. Now let's come here. So now you know how it will make a call. It will pick an element. Let's say this is 1 dot CompareTo. 1 is nothing but a student. That's what we store in the array list. So entry, first entry, for example, dot CompareTo instance at index location 1, that will get passed. Next time instance at this location, that will get passed as object. Then third time, third entry, I mean the 4th entry will get passed. First entry is fixed. So since we are making call from this first instance CompareTo, of course all object will support CompareTo, but here if you see how we are using the first instance in the array list dot CompareTo, that's how any collection class will work. It will pick 1 entry and make a call to CompareTo and then pass all other entries. Now let's come here. This means 1 entry. And we know that let me take this. We know that the return value, when it is 0, here we know that it is comparing two objects, and this comparison go for 3 times since there is a 4 slot here. One is fixed and the other 3. 0 means the object that is being compared. Let's take for the first time these two is compared. When both are 0, then no need to change any position. Rearranging these slots not required. But negative, when we are returning negative, this object proceeds obj in the sort order. So each time we will be getting, let's say this is the obj, and this will get passed as a parameter each time. Now let's take this in relation to this obj. If it is 0, nothing happens, but when we return negative, this object precedes obj. Obj is what we are comparing. Precedes in the sense, in the array list it will come before obj when we return negative. When we return positive, this object moves next to obj. This object comes next to obj, precedes obj. And if you see here clearly, now we know when this object precedes and when it comes next to the obj. So based on the condition, we are returning negative and positive here. You can return anything, negative 20, negative 25, whatever it is. But here for simplicity reason, we are returning -1 and 1. When we return -1, when the student height, here if you see, the sorting is, even though we have 3 member here, sorting is performed based on the student height. Other 2 members are not taken into account. Only based on student height we are sorting. So when student height is greater than obj in the sense, here if you see the incoming parameter obj, we are typecasting it to student inside this CompareTo, and we are naming this as student to compare. You can put any reference name, but here for easy readability we kept a student to compare. Then if both are equal, there are 2 objects we are comparing, right? One is this, whoever is calling that object, with whatever is get passed as obj. So when they both are equal, we return 0. When a student, this object's student height is more than object that is coming in as parameter, we return negative. Negative means this object precedes obj. That means obj, this object compares, this object moves towards left, or it precedes the obj. So once all remaining objects are scanned, we can say that the highest student goes in the first slot. Next, the next height, after that third height, fourth. Likewise, it will get sorted. Here you can see. If you sort it in ascending order, you have to reverse this logic. Instead of greater than here, you can put less than, or you can still keep this same condition and you can exchange -1 and +1. Here you can put 1 and here you can put -1. Alright, so that's all here. And now we provided a sorting logic, and you can see we are returning -1 when student height is, this dot student height is greater than the obj student height. That means this object moves, precedes the obj. So 1, 2, 3 we are comparing, and for example, let's say this is the highest student. That means it precedes all other element. That means the whatever location it has here, that is perfect. Suppose if the student height is the lowest one. Each time when we compare, this object come next to the obj. That means this object moves towards left. Then when we compare, it moves next to this one. That way this object goes towards the last. Alright, now in the demo we will create the student class and we will implement the CompareTo method. Here is our Visual Studio, and first we have to open class view, which you can find it here under the view menu, and if it is not there, go to tools, customize, under command go to view menu, and here when you browse you will see class view. Drag and drop it to the view menu. So you can click here and drop if class view is not here. Then click on that class view, that will get opened here. Now this is the namespace. If I go to view code, you can see FRM student, that's our form name. Namespace is IComparable EX, so we will collapse this IComparable EX, and which has FRM student, which is derived from form. This is nothing but our win form. Alright, now we will create a new class, or you can click on view class diagram. From there also you can create a new class. For now, let me go to Solution Explorer, then right click on the project name, click on add and class. We will name this as CLS student. So I'm prefixing CLS. CLS stands for class, and it's not mandatory anyhow. You can provide any name. Just for readability purpose, I'm giving CLS student, and you can see we have a class called student. Now we will save this and we will go to our class view, and you can see CLS student here. It doesn't have any member now. Now let's right click on the project name or namespace name. Here our namespace is IComparable EX, right? Right click here and click on view class diagram. So all these steps are not necessary. All we need is CLS student only. We will expand this. Resources you can keep aside, settings you can keep aside, other stuff you can move aside. We are not going to change this. Only CLS student we need to modify. So we need to add 3 members. The first member is field, and we will name it as stname. Click the stname here. Type is integer. We will change it as a string. And let it be private. Okay, we can use a smaller case string, or okay, here it has uppercase. Add field. So you can add field here itself, or you can add in the grid also. It is. So next, create a student height and type is integer. Next, click. You can add the field by right clicking here and choosing the field, or you can just click on the grid and type the field name. Next, when you click type, by default it will pick integer, or you can type whatever type you want. So the moment I hit the first key, it will show all the valid type here, and I need integer, so I'm just picking that type. So all are private members. So I just saved it. Now we can close this class diagram, and you can see in our class there are 3 private members that get added. Here I am using the Visual 2005 IDE. Even though it's old IDE, it still supports a class diagram, and if you have a later version, the procedure will be same. And if you don't want to use a class diagram, then you can simply start typing the members. And our class should implement IComparable interface. I am typing it at the wrong location. That's namespace. Here is our class. This should implement I. So here you can see IComparable, and you can read the tooltip. Defines a generalized type-specific comparison method that a value type or class implements. To order or sort its instances. So that means it's for any collection class that knows how to sort this student class instance when it implements the IComparable interface. Alright, now we will save, and if you build the solution, you will get an error stating that CompareTo method needs to be implemented. So we will be doing that here in this video. Before that, we will create the access specifier is private here, right? We will create properties. So just right click here, refactor, encapsulate field. This is a student name, right? The member name is the ST name and property name. So this is the field name. Field name is a private. Now we are defining a property, student name, and click OK here. Then perform apply, and you can see a property is created. Likewise, you have to create property for other 2 fields as well. Here, using the refactor method, we added a property, and you can also start typing the property yourself. So we have student name, getter and setter. That means property get and property set. Property get will retrieve the student name from the private field, and set will assign a value to ST name. Same goes for student height, operates on ST height here. Then student weight operate on ST weight. So both are read and write property. If we skip get, then it's write only property, you cannot read, and if you skip set, then it is a read only property. That means you cannot write. Alright, now still we have this error. That means we need to implement CompareTo method. Okay, here we already stated that student class CLS student implements IComparable, and here is our CompareTo method. So this was already explained in the slide. Now we specified how this student class can be compared. That means if we have 2 instances of class student, and here we specified which one is or how to compare 2 instances of student objects. Also here we stated that the sorting will go based on the student height. Alright, now we will build this once. Before that, we will save everything, rebuild solution. So this is a CLS student, or we can simply change this as a student. That's all here. Our student class contains 3 private member. You can see a padlock icon here. That means these are all locked members, private, and we have public accesses for these, public's property for these 3 members. Then we have a CompareTo method. So if you double click, it will directly navigate to that specific property, and you can see where the cursor stays. Alright, now we have a student class ready. In the next video, we will go ahead and start using this student class. When we click add, list, sort, all those stuff we will implement by making use of student. And we will also use array list, and we will perform sorting. That sorting will make use of our CompareTo method to compare 2 student instances. That's all here in this video. Thank you for watching. Bye.